This is lesson 7.4 on scientific notation. So you might remember some of this from last year or even in 6th grade. Scientific notation is a way to write very big or small numbers that have a bunch of zeros in a different way using a power of 10. So you don't have to write out all the zeros. So keep in mind, scientific notation has one non-zero digit before the decimal point, and then it's times 10 to some power. So if you look at these examples here, 6.2, 1.496, 2.31, 6.234, those all have one digit only before the decimal point, so a number between 1 and 9, then your decimal point, whatever other remaining digits, but there's no more zeros, and then it's times 10 to an exponent. So if it's a very large number, it has a positive power of 10, like the first two examples. And if your decimal is smaller than 1, you're going to have a negative exponent on the power of 10. Eventually, we'll talk about combining some two numbers that were in scientific notation together so we can combine our exponent rules. If we multiply, we're adding the exponents, and if we're dividing them, we subtract the exponents. So we'll get into that a bit later. First, let's review how to go from a standard form number, so something written as a normal number with a bunch of zeros, to the scientific notation form, so some decimal times a power of 10. And it's all about the decimal point. So in this first example, the decimal point is at the very end. Our goal is to get it between the 2 and the 0. So it's 2.01 times 10, and the number of swoops it takes to get to that point is our exponent. So this is 1, 2, 3, 4, 5, 6, 7, 8 times, and it is a very large number, a number that's bigger than 1, so it's a positive 8 power. Likewise on 1a, my decimal's at the end again. I want it to go after the first non-zero digit, so I want it to be 6.87 times 10 to some exponent. Let's count the swoops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is to the 10th power. So again, notice you only have one digit, then the decimal point immediately afterwards. On letter B, I want the first non-zero digit I see is the 5. So it's going to be 5.1 times 10 to some power. 1, 2, 3, 4, 5. And this time it's going to be a negative 5 because this number is smaller than 1. So it's very small. Likewise, the first non-zero digit on 1b is the 7. So I want it to be 7.25 times 10 to the 1, 2, 3, 4, 5. And again, that's negative. It's smaller than 1. So again, 5.1, 7.25 only has one non-zero digit to the left of the decimal point times the power of 10. Now let's go the other way. So it's all about, is the exponent positive or negative? Figures out which way you have to move the decimal point. If the exponent is positive, move the decimal point to the right. Think about on a number line, your positive numbers are to the right of 0. And if the exponent is negative, you're going to move it to the left. For those of you that need some direction arrows. There you go. All right, so now they give you a scientific notation number. We need to write it as a standard form number. So look at the exponent. The exponent on this first one, 6.32 times 10 to the positive 9th, means you're moving the decimal point to the right 9 times. So 1, 2 takes me to the end of the 2. So I need 7 more zeros as placeholders. 1, 2, 3, 4, 5, 6, 7. Fill in your commas. Okay. Likewise, 2a is to a positive 6, so that's moving 6 swoops to the right. So 1, 2, 3 gets me to the end of 3, 2, 0, 1. And I need 3 more zeros as placeholders. Fill in your commas. The next two have a negative exponent, so I'm moving to the left. So the exponent is right behind the 4. If I move it in front of the 4, that's only 1, meaning I need 6 more placeholders of the zeros. So if that was here, it's 1, 2, 3, 4, 5, 6, 7. And you could put the leading 0 if you'd like. 2b is to the negative 5, so again I'm moving left. So in front of the 9 is 1, so I need 4 more zeros. And then you can put the leading 0 in the front. So that, just so you see it, was 1, 2, 3, 4, 5. So that's going back and forth from scientific to standard and vice versa. Now we're going to multiply with scientific notation. Express the result in both scientific notation and standard form. So I'm going to show you 2 ways. One way by hand using exponent properties, and then I'll show you on the calculator how to do that as well. For this first one, so my decimal numbers are 3.5 times 7. So you could multiply those together and get 24.5. And if you have 10 to the negative 3rd times 10 to the 5th, our exponent properties say that when we're multiplying like bases, we add the powers. So this would be 10 squared. So if you had 24.5 times 10 squared, you should know that that's not scientific notation because you have 2 digits prior to your decimal point. So let's write this in standard form first. So if this exponent's a positive 2, it's moving to the right twice. So to the end of the 5, and then I need 1 more 0. So it's 2,450. This is standard form. And then if I want scientific notation, it needs to be right after the 2. So 2.45 times 10 to the, and if I swoop in, 1, 2, 3. So this number is scientific notation. This number is standard. And I'll show the next 2 with using the calculator. So let me go by my calculator here. So when it wants the product means to multiply. So I'm going to type this in the calculator exactly how I see it. So parentheses 6.5 times 10 to the caret button to raise it up to the 12th power. Close the parentheses, start a new parenthesis, 8.7 times 10 to the negative 15th power. So that's exactly how it looks like in 3a. If I press enter, that is my standard form. So I'm going to write that on my notes. Was 0.05655, and scientific notation states that I want the decimal after the first non-zero number, so that's going to be 5.655 times 10 to the, it has to swoop over 2 times, and it's negative. The standard number is smaller than 1. Likewise, let me type in 3b to the calculator. So 7.8 times 10 to the negative 4th. That is being squared. So type it exactly how you see it. and you get this. Now, if you see something with an E, that just means the exponent on the power of 10 is a negative 7. So this time the calculator gave me scientific notation first, which was 6.084 times 10 to the negative 7. And if I go to standard, because it's to a negative power, we need to go to the left 7 times. So in front of the 6 would be 1, which means you need 6 more zeros. So let me just double check if that was here. It was 1, 2, 3, 4, 5, 6, 7 to the left. Yeah. All right, and lastly is dividing. So I'll show you by hand using some of the exponent rules and then again on the calculator. So we want to look at the front decimal numbers, and if we divide them, we get 0.42. Our powers of 10 are being divided, so we could subtract the exponents and get 10 to the 5th. I'm going to write that in standard form first. So positive 5 exponent means go to the right. 5 swoops. So 1, 2, and then 3 more zeros. So 42,000 is standard. Scientific notation needs the decimal to be right after the 4. So 4.2 times 10 to the, and if you swoop in from that, you need to go 1, 2, 3, 4 times. So it's 4.2 times 10 to the 4th. And then on the calculator for 4a, if we go back here, we can type it exactly how we see it. We're going to make a fraction first. So alpha y equals n over d. We'll type the first one, 2.3958 times 10 to the 3rd. That's the numerator. The denominator is 1.98 times 10 to the 8th. Press enter. It gave us the scientific notation first. The power, the e to the negative 5 means 1.21 times 10 to the negative 5th. So scientific notation was 1.21 times 10 to the negative 5th, which means the standard form. It's a negative 5, so we're moving left 5. So in front of the 1 would be 1. We need 4 more zeros. And then the leading one. So that is your answer. So your assignment's going to be in Delta Math. You'll have to go back and forth between scientific and standard. And then you'll have ones that either want the product or the quotient. So remember, quotient means division. Product means multiplication. So know which operation you need to do. And lastly, the real world example. So in the United States, a CD reaches gold status once 500,000 copies are sold. And it reaches platinum if 1 million or more copies are sold. So sometimes you see like these Florida Georgia Line or Ariana Grande, Justin Biebs, sell platinum. Means they have 1 million or more copies of their CD being sold. So we're going to express the number of copies in standard notation for gold and platinum. So this just means as a normal number. So gold status is 500,000. Platinum is 1 million, so 1 with 6 zeros. We also need to write them in scientific notation. So this is 5 times 10 to the 5th power. And platinum is 1 times 10 to the 6th power. How many copies of a CD have sold if it has gone platinum 13 times? Write your answer in scientific and standard. So 13 times, well, platinum is 1 million. So we need 1 million times 3, which would be 13 million. That's standard. And then scientific notation would be 1.3 times 10 to the 7th, because you have to swoop in. There's 3, there's 6. Between the 1 and the 3 would be 7. So don't just count zeros. It's the number of swoops you need to move the decimal so that there's one non-zero digit and then your decimal point immediately afterwards. All right, so now after taking your notes, you need to go to 7.4 in Delta Math and complete those practice problems.